Hello everyone. Welcome to Tech Thursday Presents 3D Printing Basics. So today I will show you a few things about 3D printers and how they operate. Also the softwares that we use in 3D printing. There's a lot of different softwares out there and a lot of it's free. So I'll show you what we use here at the library, and also the price and time of printing, and then some ideas for what you can print and what you can have submitted to print at the library. So right here, I have a Monoprice Select Mini V2. This is the printer that we have at the library. We actually have 3 of these that we've had for a couple of years. This printer itself is $220, so it's not very expensive. I mean, it's a pretty good chunk of change, but it's actually affordable for just like an average person. And this is showing the different parts of the printer. So this is the Z-axis. The Z-axis goes up and down while you're printing. Each layer gets higher and higher. And then there is the X-axis, which the extruder here that extrudes the plastic out, moves back and forth on the X-axis, and then the Y-axis, which is on the print bed, goes this way, and this bed actually moves forward and backwards. So it moves 3 different ways while printing, and that allows it to do all kinds of different designs that you create. So this little cat here was printed on this bed. There's also a couple other things. There is the SD memory card slot, so you can hook your printer right up to your computer and print that way. But we actually download print jobs to a SD card, and then you insert it into the slot, and then you can print from there. What you do is you use the display and control, and you can choose your print job from there. It's actually pretty simple. The display and control, it's not a touchscreen. You just use this little dial here, and there's a push button in the middle. And with that, you can do all kinds of different things. So how 3D printers operate, they're actually very similar to a normal document printer for what you need to send a print job. So with our printers, the print job is printed, like I said, via micro SD card inserted into the printer itself. And just like a regular printer, you can send it wirelessly, you could use an USB drive, an SD card, or you can actually have it hooked up to your computer. So it works very similar in that way. And then the controls on the printer select the specific file in using the display and wheel. So with the type of filament that we use, the print bed will heat up to about 60 degrees Celsius, and that's the Y-axis where the print bed, what prints onto. That is about 140 degrees Fahrenheit. And then the extruder nozzle, where it like spits out the filament or the plastic, that will heat up to about 200 degrees Celsius, and that is about almost 400 degrees Fahrenheit, getting pretty close up there. In the plastic filament, when it begins to melt and the nozzle deposits at the filament, the lines of melted plastic get lined up onto the bed, and each part of the axis moves in different ways to make your print job. And so they keep building and building until it's all the way complete. And then once it's finished, it moves forward, and then you can remove your piece. It's hot, like it's already cooled like almost instantly, so that is solid. So some important settings while you're printing, infill is how dense your print is, and it determines the strength of your print. So at the bottom here, this is probably about 20% infill. So that means when you're printing your job, it's not going to be solid inside. It will just be filled to about 20%, and that will use less plastic. So this is probably about 60% filled up, and this is very close, probably about 85%. It's very full, and the more dense, the stronger the item will be. So depending on what you're printing, you'll want something stronger. So some more settings that you can set up when you're doing your printing are skirt, brim, and raft, and those add plastic surrounding the edge of the print, and it keeps them from curling up, because sometimes when you're starting your job, you'll have a hard time getting the plastic to set on the bed. And so when you use these different adhesions, it helps just get your job more straight, and no curling will happen. And also your temperature is very important. Depending on what type of filament you use, you might have to have it hotter or cooler. So you really have to pay attention to the filament and the temperature that you use. So we always use the same filament here. We have not changed filaments, which I like that, because the filament we use is the most recommended. And that makes things simple. We can just pretty much leave it the same temperature. And then another setting that's pretty important is the wall thickness. So that determines how thick the outer walls of the print, and that will give it rigidity. So if you need something with a really solid wall, you can change those settings. And some other things to note, the measurements when you're doing printing and 3D printing are going to typically be in millimeters and Celsius. And a lot of the software has ways that you can change the print settings. And I recommend just to leave it in millimeters and Celsius. You'll get used to this very quickly. And millimeters are a lot easier to work with once you get used to just recognizing millimeters. So that will be good to do. And any overhanging parts need to be supported. If you don't support them, you'll find out very quickly that they will not work. So if you are printing, like the dog at the bottom here, all these lines running up, those are supports. So if you tried to print this leg and you get up to about this right under his chin, if you don't have any supports there, you're basically printing plastic onto air. And when plastic lands on air, it's just going to droop down and fall. It's not going to, if there's no support, then it won't stay there. So, so he looks all nice and good after the supports are removed, because with the supports, he was able to be printed well. And you can print as large as your print bed allows. So if you have a bigger printer, you can print bigger items. So our print bed, the max size is 100 by 100 by 100 millimeters. So if you try to print anything bigger than that, the system, the software you're using will first of all tell you that you can't, and it just, the printer just won't go that far. So you really have to think about that while you're planning your design. Also, 3D printers have many settings and they require a lot of trial and error. I can tell you personally that I've failed a lot of times and I've learned each time. So being patient is good, and just keep trying. And then for our filament, we use PLA, and that's one of the most popular filaments, mostly because it has like a variety of shades and styles, and it's kind of the most safest. It doesn't have a lot of fumes that come off of it. There's low smell. Another type of filament is ABS, and it tends to have a really like burny smell when making it, and you don't want to have it in a non-ventilated area because it's not really great to breathe in. Not that you should, you know, stand next to the machine and sniff in the PLA filament, but it's a lot safer compared to the other ones. Also, it is made generally from cornstarch or sugarcane, and it's biodegradable. It does take a lot of time to break down though, like if it's in like the garbage dump. So it's good to try to recycle filament. There's different ways that you can do that. So when you have supports and adhesions, you're not gonna, you know, you're gonna pull those off and you could just throw them away, or you could, you know, recycle them. Not a lot of local recycling places in Zanesville. I know our recycling place does not take PLA filament. So there's ideas on the internet of things you can do. There's machines where you can use your recycled filament and make more filament. There's lots of different ideas that you can do things, make little keychains and stuff. So that's about our filament. So next we're going to talk about the software for 3D printing. The website that we use here at the library for designs to share, and you can just find all kinds of designs. It's Thingiverse.com. So it's a collection of free, nice 3D files from thousands of people. So if people get on there and they share their 3D files, you can easily download them. You can just find something you want, hit print. And it may or may not be customizable. So you just have to look at the uploader's permissions to see that. But it's web-based as well, so you don't have to download an app or anything to use it. But once you have something from Thingiverse, you can go to Tinkercad if you want, and then you can kind of remix it and make it your own. So Tinkercad allows you to design your own 3D files. So you don't even need a 3D file. You can start from scratch and build your own item. You can take pre-made shapes, such as cubes, spheres. They have all kinds of different shapes, and you put them together. They have, you can just like merge them together, or you can even use like voids, which are like holes or negative space to create other shapes within a shape. And this is web-based as well, and it's free. And like I said, you can take things from Thingiverse and upload it into Tinkercad and kind of remix it. So it's really cool. And it's not the only 3D CAD program out there, but this is the one that we use and I really like it. And the third piece of software that we use for 3D printing is Cura. So this is a slicing software, and this is very important for 3D printing. So it takes your 3D model and it slices it into layers. And that's how the printer knows how many layers are needed and where to place them at. So once you get your Cura in it, it tells the printer what settings are. You put your infill, the temperatures, where on the print bed it wants it at, and it puts it on an SD card and you put it in the printer. Then the printer knows where to print everything and how many layers. So that's how that works. And this is a program that you would need to download. So that's ultimaker.com. You can download Cura. It is free. So you can generate G codes, and that's what it's called. Once your 3D model's been sliced, it turns into a G code. So next, we're going to talk about the prices of 3D printing. And this is based off of the PLA filament that we use here at the library. And when we bought our filament, it's about $20 to $25 per roll. So you can definitely get more expensive filament. You know, there's different colors, there's a lot of styles, but this is based off of what we have here. So these cubes on this page here, they are at 100% infill. So they're fully compact, they're very dense, they're full cubes. So the first cube is 10 by 10 by 10 millimeters, and it's a 1 gram cube. And for 1 gram, it's going to cost about 3 cents, 0.025 for that cube there on filament. So, and it's completely full on the infill. And to print that, it's going to take about 17 minutes. So not too long, but for a tiny cube, so if you don't know what 10 millimeters is, it's a centimeter. It's about less than ½ an inch. So not very big, it's like that. The next cube is 20 by 20 by 20 millimeters, and that is going to be 10 grams. So to print that cube, it would cost 25 cents. And again, it is at 100% infill. And that's about a little over, about 3/4 of an inch. So it's very close to 3/4 of an inch. And to print that, so I mean, it's going to be about this big all the way around. It's going to take 2 hours and 19 minutes. And that's basically because it's all the way filled. When you have 100% infill, it's going to fill every single layer completely full by, you know, however small you have each layer set. So it will take a while. So this next cube, which is 40 by 40 by 40 millimeters, which is a little over 1.5 inches. So not much bigger, but twice as big, I guess. So that's going to be 80 grams, and that would cost $2 in filament. So the prices are based on how much filament. And that would take 18 hours and 15 minutes. So it would take quite a while to print that little cube, 100% infill. And just for a reference, so our print bed is 100 by 100 by 100 millimeter max size. If you were to print 100 millimeter cube, which is about 4 inches all the way around, so probably about that big, that would be 1,241 grams, and that would cost about $31 in filament. So, and that's if you had it 100% infill, it'd be a very dense 4-inch cube. So just to compare, if you were to fill these at 20%, because you don't need to fill everything at full infill, it just depends on what you're using it for. The 10 by 10 cube would stay at 1 gram and stay about 3 cents, but it would take 9 minutes to print. So that's almost half the time. So just changing that infill is going to make a significant difference in that. And then the 20 by 20 is going to go down to 4 grams and from 25 cents to 10 cents. So that's a pretty big difference. And instead of 2 hours and 19 minutes, it's only going to take 37. So that's also a huge difference. So you really want to pay attention to how much infill you need and not do more than you need. So for the 40 by 40 by 40, it's going to go down to 25 grams and it's only going to cost 63 cents. And instead of 18 hours and 15 minutes, it's going to be 3 hours and 15 minutes. So that's a huge difference. So the infill is very important, and all your settings are important, and they're going to make a difference. And that's what the trial and error comes in. So the next thing I'm going to show you on pricing. So here's the cubes again, and then this is Flexi Rexy. He is an articulated print design that someone had created on Thingiverse, and it's about 28 grams, and he is 81 by 60 by 13 millimeters. So he's taller and wider, and width more than these. Well, he's not wider than those cubes, but so for 28 grams, it's going to cost 70 cents. So just because of all his design, it's going to cost less. So the full cubes are going to be a lot different than something like this. And then also, you wouldn't need to print Flexi Rexy at 100% infill, so that's going to be even less once you change that. I would probably do it about 30%. That would be good. It'd still be durable. It wouldn't need to be completely solid to withstand. It's a great design. It's already strong, so pretty good. So next we're going to talk about just the design process when you're creating design. First, you need to identify the problem, what's your challenge and what are your limits and how can you solve it. 3D printing is great for that. What's the challenge? I don't know what to print. That's always a question. What should I print? We'll find a problem. That's a great way. Maybe something's missing or you need to replace a part. So that'll be your first step, is deciding what to print and finding a problem to solve. So then you would explore what have others done and gather materials and play with them. So maybe you can look at some other 3D prints and you can come into the library and check out and see what we have. It might give you some ideas. And then next you would need to design your print. So you need to think up some ideas and then pick one and make a plan. So you make a drawing or a model, you can get on Tinkercad and start creating that idea. And then next you will create your idea. So you use your plan to build your idea. And then after that, you need to try it out, test your idea, and then once you've tried it out, make it better, because you can always make everything better. How can you be improved? How can you modify your design? Try again, go back through the process, identify the problem again, and keep going around and around. It's just another way to think of things. And I got this from the works.org website, so if you're interested in more about the design process, you can check that out. So again, what to print? Flexi Rexy. I actually have him here. So this is Flexi Rexy, and as you can see, he's articulated, which means that he can move. And this was all printed at one time. So this was printed on the print bed like this, and it made each layer, and they're all interconnected. So that's really cool, and it really shows the capabilities of 3D printing. The next part is 3D replacement parts. So I have this gear down here. I actually had a customer come in who needed a replacement gear for his planer, which shapes like wood planks and stuff. And so we're trying to figure out how we can replace that. And actually somebody on Thingiverse had this design, and it would print out. This is not the actual picture, but this is the picture that they had on Thingiverse, and they printed theirs in black. And so now their design matches with the original, which is the white one, and they were able to fix their part. A lot of times parts, they don't have new parts. The manufacturer closes down, you're no longer able to replace it. So 3D printing allows you to create your own things and replace things. One thing I love doing is customizing items, like customize everything. One of the first things I printed was my name. So I made my name on this little plate. I just like have it up. It's like a little piece of art, I guess. And then again, find a problem and design a solution. Some other things that people have created is the toothpaste squeezer. So you put your toothpaste in there, and then it allows you to squeeze every little ounce of toothpaste you get out of there. I know my son loved that. So there's lots of different things you can print. And one of the great ways is just to go like on Thingiverse or any of the other dozens of websites and just check out and see what other people have done. So we do have MCL's printing services here at our library, and it started in about January of 2019. So a couple of things about that is you can get one print per patron per month. This is free, there's no charge. And all you need to do is upload your 3D files through a form on our website. So you do need to have a Gmail account to upload those files. If you're having trouble with that, we can always help you. So once you've uploaded those, they'll be accessed and printed at our library. And then you'll receive a phone call once it's completed, and then you have 2 weeks to pick up your print job. So if you go onto our library website and you go under Find It, you'll see 3D printing. So I have a link down there, and that's basically where you go find it, and then 3D printing. So you can check that out and give us some prints to do. It's so fun, and I think everybody should try it. It's something that's really going to change the way, I mean, people are already printing in lots of different industries and stuff like that. So there's a lot on the subject. So thanks, guys. That's all I have for you today. And I'm Jasmine once again, and have an amazing day and stay safe.